We now learn about definite integrals. Now, a definite integral is written as follows. The integral from a to b of some function f of x. Now, a and b are known as the lower limit and the upper limit of the integral, whereas f of x is known as the integrand. So what are a and b? Well, let's see. Let's say we have some function with a curve looking something completely generic, something like this. Okay, that's y is equal to some function f of x. Well, put simply, a and b, the lower and upper limits, are simply two values of x. For instance, it could be a is here and b could be there. So when we write the integral from a to b, we're studying this function f of x between these two values of x, a and b, included. And in fact, this highlights something quite important. The function f of x needs to be defined at both the points a and b, and furthermore, f of x needs to be continuous over the interval ab. Most introductory courses in calculus will only involve continuous functions over the closed intervals a, b. So how do we actually evaluate a definite integral? Well, the formula is the following. The integral from a to b of f of x is equal to capital F at b minus capital F at a, where capital F is a function, capital F of x, and it's the antiderivative of f of x. And we already know how to find the antiderivative of a function, and that's exactly what capital F is. Another way of writing this is as follows. The definite integral from a to b of f of x is equal to capital F of x, the antiderivative, written in square brackets with a and b written as so. Now, both of these formula mean exactly the same thing. They're simply different notations. So keep in mind, when we write this in square brackets, capital F of x with a and b written as so, it means capital F at b minus capital F at a. So, now that we've seen the formula, let's go ahead and work through a couple of examples. As a first example, example 1, let's evaluate the definite integral from 1 to 2 of 6x squared. The first thing we need to do is find the antiderivative. That's capital F of x, which equals to the integral, the indefinite integral, of 6x squared. Using the power rule for integration, we can go right ahead and say that this is equal to 6 over 2 plus 1 times x to the power of 2 plus 1 plus some constant of integration, c. We carry on. That's 6 over 3 times x to the power of 3 plus c. 6 over 3 is 2, so that's 2x cubed plus c. So that's the antiderivative of the function 6x squared. But now, one important thing to make a note of is the fact that when we're dealing with definite integrals, we don't have to worry about constants of integration. So we can go ahead and cross out c here. In fact, we can rewrite this, capital F of x is equal to 2x cubed. Now that we have the antiderivative, we can go ahead and evaluate the definite integral. And we write the integral from 1 to 2 of 6x squared is equal to the antiderivative, capital F, at 2 minus the antiderivative at 1. Another way of writing that, of course, is in square brackets as 2x cubed, 1 and 2, like so. So let's go ahead and calculate this. So this will equal to 2 times 2 cubed, that's the upper limit, minus 2 times 1 cubed, that's the lower limit. That's equal to 2 times 8 minus 2 times 1. 2 times 8 is 16, so that's 16 minus 2, which is equal to 14. And we're done. We've just evaluated this definite integral. Let's look at another example. Example 2. let's evaluate the definite integral from negative 2 to 3 of 2x plus 1. So again, the first thing we do is find the antiderivative, that's capital F of x, which equals to the integral of 2x plus 1. Using the power rule, we can integrate this in one go, and go right ahead and say that this is equal to x squared plus x plus some constant c. But once more, remember, when we're dealing with definite integrals, we don't have to worry about constants of integration. So we can go ahead and cross that out and write that the antiderivative capital F of x is equal to x squared plus x. Now that we've done that, we can go ahead and evaluate the definite integral. So this definite integral from negative 2 to 3 of 2x plus 1 is equal to capital F, that's the antiderivative at 3, minus the antiderivative at negative 2. Again, we can write this in square brackets as x squared plus x, and we write negative 2 and 3. So let's go ahead and calculate that. The antiderivative at 3 is therefore 3 squared plus 3, and we have to take away from that the antiderivative at the lower limit, negative 2. Now, because there are two terms, write them in parentheses, and that would be negative 2 squared plus negative 2. 3 squared is 9, so plus 3, minus, in parentheses, negative 2 squared is 4, plus negative 2 leads to negative 2, or simply minus 2. 9 plus 3 is equal to 12, minus 4 minus 2, which is 2. And finally, we can state that this definite integral is equal to 10. And we're done. The next thing we'll be learning is what definite integrals actually mean. What does the value, for instance, here of 10 represent? So we'll be learning how to interpret our results when we do definite integration. I hope that helps.